Okay, we are going to do Unit 5, Formative 1 with pre-calculus right now. We're going to have a chit-chat about this problem. We're going to have a chat. That's what they say in the UK. Let's go have a chat. Okay, so I'm just going to start working this problem out. Let me first move 2 sine of theta over. I should go slower so I don't make this super messy. All right, so what I notice right now is tangent is equal to sine over cosine. So why don't I go ahead and just, I don't know what I'm doing here. I'm just trying stuff, right? When you start one of these problems, you're just, if it doesn't go where you want it to, you just erase it and start over. Well, now that I've rewrote tangent as sine over cosine, now I can see I've got 2 terms here, 1 term, 2 terms, and each of those terms has a sine in it, okay? So I've got a couple options here. I can make this denominator, currently the denominator of the second term is a 1. I can make that into a cosine, which, I'll show you that too. But I'm not going to do that right now. I'm just going to pull the sine out of each of the terms. So I'm going to GCF out, or undistribute, or factor out sine of theta. Okay, so it's just a choice I'm making. I'll show you the other way too, because we're going to get the same answer. Okay, you might have to pause to take a look at that if you have trouble factoring. So at this point, now I have 2 numbers that I'm multiplying, right? I've got 1 number here and 1 number here. And those 2 numbers, when I multiply them, equal 0. So I have to set them separately, each equal to 0. That's called the zero product property. You use that back in Algebra 1. So if I set sine of theta equals 0, I know that the sine, let me just draw, is 0. 0 and pi. So I'm just going to write theta equals pi k. Boom, done. Okay. The other side, or the other number that I'm multiplying to get 0, that could actually also be 0, is 1 minus cosine of theta minus 2. I have to set that also equal to 0. So if I go ahead and do that, I'll get 1 over cosine of theta equals 2. Now this is usually where I just write the answer and people get confused. So let me just rewrite this and show you. Just pretend like you don't know how to cross multiply. Okay, that's a 2. This is, if I were to cross multiply this, and normally you're doing this in your head, but I'm just going to show you. 2 cosine of theta equals 1, and then you divide both sides by 2. You end up getting cosine of theta equals 1/2. Now you can figure that out. As soon as you get to here, you can look at that and say, well, cosine of theta has to equal 1/2. If you know that 1 over 1/2 is equal to 2. Because if you do keep, change, flip, in your head, you should know this, at this point. All right. So just thought I'd show that to you anyway. So where am I at? Okay, I've got 1 solution right there. And now I've isolated this cosine of theta equals 1/2. So let me go ahead to the next page and rewrite that. Cosine of theta equals 1/2. Okay, so that's a 1/2. All right, those are tall angles. So if you know your unit circle, that is going to be pi over 3 and 5 pi over 3. Because think about it. Oh, shoot. Let's try that again. If you are still having trouble with the unit circle, you're going to think, where's the cosine? Where's the x value going to be the short distance in one of these triangles? It's going to be in the tall triangle because, there's your right angle. This distance is short, this distance is long. So that makes the short distance 1/2, and that makes this the tall angle. So if you had trouble understanding what I was just saying there, go back and learn the unit circle again. Okay, so we've got, like I said, a tall angle. This is pi over 3. And we also have cosine is also positive here at 5 pi over 3. So the other 2 solutions are theta equals pi over 3 plus 2 pi k. And theta equals 5 pi over 3 plus 2 pi k. The reason we're using 2 pi k here is because to get from pi over 3 to my next solution, 5 pi over 3, that distance is not the same as this distance. So if I go this distance and then I go to the next solution, I'm going to have to go a different distance. So I'm going to choose to go all the way around again to get my next solution for pi over 3 for a coterminal angle. And same for 5 pi over 3. Okay, with the previous problem, or the previous solution over here, we're using pi k because the distance from 0 to pi and back to 0 again is the same distance. So I can find an infinite number of solutions by just adding pi to whatever angle I have. All right, the other, let me just show you right here, the choice that I made. I think this is a good shot right here, right here. So let me go ahead and pause this for a second. All right, so originally when I did this problem, I chose to, from this point where I circled in green here, to factor out a sign because each of these two terms had a sign in it, okay? But let's just say I made another choice at that point. And I decided to make the denominators the same so I could add them together. So let's just say I did that, okay? So here's just another option here, an algebraic option. I'm going to go ahead and multiply this fraction by cosine over cosine. So, okay, that makes the numerator, that makes the two fractions both have a cosine of theta in the denominator. The denominator is the same. I can add them together. So now the new numerator would be sine of theta minus 2 sine of theta times cosine of theta, right? And you know what? I'm just going to leave this over cosine. Oh, yeah, cosine of theta. Okay, so now what's happened here is I can, I don't know, I can manipulate this. Let me see. All over cosine of theta. Now I'm going to go ahead and maybe I'll rewrite this as factor out a sine. So sine of theta equals, or times 1 minus 2 cosine of theta, right? And that's over cosine of theta. Just factor out a sine out of each of the two terms. Well, now looks like I'm going to end up with tangent of theta times 1 minus 2 cosine of theta. Really, I mean, this is the same thing. So this ends up being, where's the tangent equal to 0? Same place, and then we end up with, when we set this equal to 0, we end up getting the same thing. So we end up getting 1 equals 2 cosine theta divided both sides by 2. We end up getting cosine is still equal to 1/2. Okay, so if you try something algebraic and it doesn't get you where you want it to go, just erase it and start over. And just because you do something differently than your neighbor or your friend doesn't mean it's wrong. It just means it's a different way of getting the same answer. Might not be as efficient, but you know, trying to just talk about math here. So did I give you the answers? I did. So here are the general, since the original question is asking for the general solutions, the answers are right here. Theta equals pi k, and theta equals pi over 3 plus 2 pi k, and theta equals 5 pi over 3 plus 2 pi k. All right, peace out.